Hello friends, today we'll learn the topic balancing of rotating masses. We see many rotating machinery around us like pump, blowers, generators, turbines, electric motors, and balancing of its component or maybe the whole machine is very important to avoid the premature failure of the machine. Basically unbalanced it will leads to vibration, noise in the component, and it will create an unpleasant effect, and will reduce the life of the machine basically. So the balancing is very important in every machines. So here is the outline of today's topic. What are the objective of the learning, what are the causes, and what is the need of balancing, what are the different methods of balancing, balancing of masses rotating in single plane, balancing of masses rotating in different planes, what are the objective of the learning, what is the need of balancing, why the balancing of rotating masses is needed to learn, and what are the different methods, how the balancing is carried out for single mass or maybe the multiple masses in single or maybe in different planes. So here we see the causes of unbalance, generally errors in the manufacturing, or we see the tolerances are not properly achieved during the manufacturing, or maybe when we assemble the component during the assembly proper tolerancing is not done. That is also main cause of unbalance. Non-homogeneity of the material, unsymmetrical shape of the rotors. Due to our functional requirement we change in the shape of the rotor, and it will create an unbalance in the component as there is a not proper division of mass on both the side. There is a design errors again, it will create an unbalance. Then what is the need of balancing for smooth operation of a machines or maybe components? Balancing is needed. Generally most of the machines working at high speed, and at high speed unbalance will create a vibration and noise. We know that unbalance basically due to centrifugal force. Whatever the unbalanced mass, it will rotate about the axis of center of rotation, and that mass will create a centrifugal force, and that centrifugal force needed to balance, otherwise the magnitude of centrifugal force is huge at high speed, and it will bend the shaft, or maybe it will create a vibration and noise in the component. So need of balancing at high speed is very important. Again, balancing will increase the service life, enhance the quality of the product, or it will also increase the productivity. Then it will reduce the maintenance or overall cost of the component. So here are the methods of balancing or rotating masses. First case, balancing of a single rotating mass by a single rotating mass in same plane. Balancing of a single rotating mass by two masses rotating in different planes. Balancing of several rotating masses rotating in same plane. Balancing of several rotating masses rotating in different planes. These are the four cases. One by one we see all these cases. So first we see balancing of single rotating mass by single rotating mass in same plane. If there is any unbalanced mass, so here in the figure we see the M is the unbalanced mass, and as the axis of rotation of unbalanced mass, it is not on the axis of rotation of the shaft, so it will create a centrifugal force, and this centrifugal force, as we know that the centrifugal force is mr omega square, and as our machines rotating at high speed, your centrifugal force it is omega square, so it is increases in multiple values. So whatever the centrifugal force, it has a huge magnitude at high speed. So the balancing is very important in this case. In this method actually we put balancing mass in the opposite direction, exactly in the opposite direction on the same plane, and MB is nothing but basically it is the balancing mass, and RB is nothing but R suffix B, it is the radius of this balancing mass. Then omega square, we know that the speed is same as we locate the mass on the same shaft and on the same plane. This is a simple method of the balancing in which actually the balance mass is put exactly in the opposite direction of the unbalanced mass. Second, balancing of a single rotating mass by two masses rotating in different planes. Now, as we discussed the first method, in this actually we put the mass in exactly opposite direction. It will balance the centrifugal force, but it will produce basically couple, and this couple act on the shaft. To avoid the couple effect, basically instead of a single mass we put two masses at different planes. It is not exactly on the same plane but at a different plane, and basically this two masses, it will avoid the effect of unbalanced couple which arises in the previous method. And in order to completely balance the system, we provide two masses. M is the single mass and M1, M2 are the two masses we put in the, this may be we put in the two direction of this unbalanced mass, or maybe on any one side of the unbalanced mass, where we can easily provide or easily locate this balancing masses. So this is again a simple method to completely balance the system to avoid the effect of centrifugal force and unbalanced couple also. This is a complete balancing method we can say. Next is the balancing of several rotating masses rotating in same plane. As we know, in the machines there are different components, and suppose every component is having some unbalanced mass. In that case we see several rotating masses create an unbalance effect, and it will create a vibration or maybe the noise of the machine component. In that case, generally do we will find the resultant component of this. Basically in this case actually all these masses we consider on same plane, so we can find out the resultant effect of all these unbalanced masses, that is a resultant centrifugal force. And also we find out the angular position of this resultant angular force, and we put the mass at that angular position which of same magnitude. Again, to find out the resultant force magnitude and its angular position, basically two methods we adopt, that is a graphical method or maybe the analytical method. Next, that is balancing of several rotating masses rotating in different planes. Now again, as we discuss about the machines, rotating machines, there are many components in rotating machines. So we consider the several masses as a unbalance created by every component. It may be a small mass, but it will create an unbalance, and overall effect it is on the working of the machines we generally observe. So balancing in such cases is done again by find out the resultant force. But to find out the resultant force we require that the total effect of this total unbalanced forces on the one plane, that is on a single plane, so that is called as reference plane. So we consider the effect of all these unbalanced masses on a reference plane. Then we find out the resultant force magnitude and its angular position, again by two methods, that is graphical method or maybe the analytical method. And in this way we see that the balancing of the single mass or maybe the multiple masses can easily achieved by graphical or maybe the analytical method, and which is easily adopted for any rotating machines. Thank you.